Okay, chapter 2, we're going to learn about two different types of reasoning. The first type of reasoning is inductive reasoning. From your reading last night, can somebody refresh me the mind of what inductive reasoning is?
Inductive reasoning is...
Okay. So, inductive reasoning, we find out by trying to recognize a pattern. Okay, so it's all pattern recognition. For example, the ancient people, they looked out in the morning and they realized the sun rose in the east last week. And then 6 days ago, the sun rose in the east. Then 5 days ago, it rose in the east. This morning, the sun rose in the east. So, using inductive reasoning, what can they say about the sun? About tomorrow? It's going to rise in the east. Okay, they did not have any way to prove it deductively, which is our next type of reasoning. They just saw a pattern that the sun rises in the east every day previously so that tomorrow it will rise in the east. Yes? No, not on this planet. And then we can use science and mathematics to prove that it will never rise in the east on this, west on this planet. So, I'm going to take these 4 blocks. And I want to know what that last block is going to look like. We're trying to recognize a pattern from this block to this one to this one to this one to come up with what the last one's going to look like. Yes? It's going to have a dot in the bottom right-hand corner. Okay? What you just did, Ben, was you made a conjecture. Basically, a conjecture is looking at previous patterns and trying to guess what something's going to be based off of that pattern. So he saw it started here, and then it rotated counterclockwise 90 degrees in between successive items. So his next one put it in the bottom right-hand corner. So some of your problems, you are actually going to be looking at pictures to find patterns. Other problems, you are going to be looking at number series to try to recognize a pattern for the following number series. So there's 2 things I want here. I would like you to try to recognize what the pattern is and then tell me what the next 2 numbers in the series are. Somebody else. Anybody recognize what I'm going to do between successive numbers? Yes. You're adding 5. So your guess is, hey, we're adding 5. Let's check to see if it works. So what is negative 6 plus 5? Yep, it's negative 1. Plus 5. Plus 5. It works. So what are my next 2 numbers? 14 and 19. So on problems like this, you need to try to recognize a pattern. Then you want to come up with the next numbers. Pattern. Anybody recognize that pattern? Negative 1 to negative 1 quarter, 16, negative 4.
That's a negative 1.
Divide by what?
Negative 4.
Divide by negative 4. If you need to, get a calculator out. What's 1 divided by 4? Negative 4. So 1 divided by negative 4 is negative 1 quarter. What's negative 1 quarter divided by negative 4? Are you sure? Negative 1 quarter divided by negative 4 is what? It's negative 1 quarter times 1 over 4. Flip it over and multiply. So it's not divided by negative 4 because I would end up with a negative 1/16. What? Any other guesses at my pattern? Does it have a pattern?
No.
So why did you say negative 4, Ben?
Because it works for the first one, so
It worked for the first one.
for the second.
Does it work for this one? What's 16 times negative 4? Divided, yeah, so this one, it works for this one. It works for this one. It doesn't work for that one. Okay, so it does kind of think that there's going to be a pattern. There is. So if I take my number and multiply it by negative 4, and then take the reciprocal of that number that I get, let's see if that works. What is 1 times negative 4? Negative 4, and then flip it over, what do I get? Negative 1/4. Let's take that 1 times negative 4. Nope, it doesn't work. This one right here has no pattern. Okay, there is a pattern to get from here to here that works to go from here to here, but it is not the same pattern that goes from there to there. So one thing I wanted to point out on this one is that, hey, just because they give you a sequence of numbers does not mean that there's going to be a pattern. You're going to have to try various things. Show me the things that you tried. There are going to be times that, hey, there may be a pattern, but you can't come up with it. Show me the things that you try to find the pattern. The next one does have a pattern, though. Hopefully you recognize it. What is that pattern? Divide by negative 2. So 100 divided by negative 2 is negative 50. Divided by negative 2 is positive 25. Divided by negative 2 is negative 12 and a half. Divided by negative 2 would be positive 6 1/4. Then I would get a negative 3, and what's half of that? An 8. So you can continue the series. So big thing is look for patterns and then try to extend them. So the last thing that we need to discuss today is a counterexample. A counterexample is an example that proves something false. I only need to prove something false one time. So what I want to see if we can find a counterexample of the following. The sum of 2 prime numbers is always odd. No, always even. For example, 3 plus 5, they're both prime, they're even.
Always.
So this is and that's the always. Always. Okay? So I need to come up with an example that proves this false, and then I prove it false for basically everything. 2 and 3. So 2 plus 3 is what? 5. Is 5 okay? So we write this down, and for your formal explanation, this is what I need to see for a response. 2 and 3 are prime. Correct? So I need to show they're both prime. The sum of which, what's their sum? Is 5, which is not even. This is a C answer. That is an A answer. Any questions on the difference between a C answer and an A answer? Okay, that's it for today.